everyone, and welcome to Algebra 2, Chapter 2, Lesson 9, Absolute Value Functions. We're going to start off with a look at what absolute value functions are, and then we're going to look at transformations and graphing of them. Absolute value functions are functions that have absolute value expressions in them. So the parent function of this is just y equals the absolute value of x. The domain is all real numbers, and the range is all positive numbers and 0. So y is greater than or equal to 0. And the vertex is 0, 0. Now you'll notice that it creates two straight lines, one going up and to the right and one going up and to the left. These lines have opposite slopes. One is +1 and one is -1. Okay, so that's true for the parent function, but if you do a stretch or compression, it's not always going to be true. So you have to be careful with those. Now let's look at those transformations. You may recall from earlier lessons that there are 6 types of transformations we usually use in Algebra 2. The first one is a horizontal translation, where we subtract a value from the variable. So you put parentheses around the variable, and then inside those parentheses, you're going to subtract whatever number it is. Now, if you're moving to the left, you'd subtract a negative value. If you were moving to the right, you'd subtract a positive value. For a vertical translation, you're adding a value to the entire function. So this means that right at the end of the function, you would just do plus whatever number it is. And that number would be positive if you're going up and negative if you're going down. For a horizontal stretch or compression, you would multiply the variable by the reciprocal of a factor. So when you're doing it to the variable, you put parentheses around the variable, you flip whatever number they gave you, and then that goes inside those parentheses. So in those parentheses, it's just your factor times the variable. That's it. For a vertical stretch or compression, you multiply the function by the factor. That means you put parentheses around the entire function. The factor goes on the outside of the parentheses, and you distribute it to each term. But just be careful not to multiply it into the absolute values. That only works some of the time. So in order to emphasize the vertical stretch or compression, I tell you guys to keep the number on the outside of those absolute value symbols. Finally, the reflections. Across the y-axis, you're multiplying the variable by -1. So again, you're going to go find your variable. Right next to it, you're going to change its sign. For a reflection across the x-axis, you're multiplying the entire function by -1. That means, again, you're putting parentheses around the entire function, the -1 on the outside, and then you can distribute it to each term, being careful not to go into the absolute value symbols. Let's take a look at some examples of these so that you can get a better idea of what they're talking about. In example 1, we're asked to perform the following transformations on the parent function. In part A, they want us to go 1 unit up, and in part B, they want us to go 3 units to the left. So I recommend pausing this video and doing those, and then hitting play to see if you're right. To move it 1 unit up on the graph, it's very easy to just say each point goes 1 unit up, and then you draw it with the slope of 1 going in this direction, and the slope of -1 going in that direction. So that's the easy part, but writing your function is a little more challenging. This is a vertical translation up 1. So all I'm going to do is on my parent function, I'm going to do +1 right at the end here, outside of the absolute value symbols. So let me show you what all of that would look like. So on my equation, you can see that I have the absolute value symbols here, and then it's +1 afterwards. In my graph, I have just taken each point and moved it up 1. So this red one is the transformed function. Now, to go 3 units to the left, remember, you have to go inside the absolute value symbols, and then you do minus, and this is -3, because left is a negative direction. So minus -3 in there would look like +3. And then you would take your parent function and move it 3 units to the left, and that's easier to do. So you just count 3 units to the left, that's where your vertex goes, and then you use that slope again to get the lines. So let me show you what all of that would look like. I have my function, and you'll notice that I did simplify my minus -3 to be x plus 3 inside the absolute values. And then I moved this 3 units to the left. Also notice that this is a horizontal change, and that's why I went into the absolute values. In part A, this was a vertical change, so I stayed outside the absolute values. Okay, let's talk about the vertex and what these transformations mean when we're translating it left and right or up and down. If I have a horizontal translation by h units, that will move the vertex to the x value of h. And notice when it goes into the function, this is a horizontal translation, so you subtract h from your variable. So it looks like x minus h. And then k is a vertical translation. So in the function, it looks like plus k here, but that's actually the y value of the vertex. So if you want to know the vertex and you have something where there's no multiplication here with the x and there's nothing else going on around here, you can literally just take this number here. You do want to change whatever sign is right here and put it with the value that's added on the outside. So that can help you find your vertex, and as long as there are no other stretches and compressions happening, you can easily graph your function from that. Just find the vertex and then use the slope of +1 and -1. So let me show you that in an example. In example 2, we're asked to translate the parent function so that the vertex is at the point -5, 3. And again, I do recommend that you pause this video and try it on your own first. To write my function, what I would do is take this -5 and put it in here where the h would be. So it's x minus -5. And then I just simplified that to be a +5. And then I would take this k value and put it at the end here. So I just did +3 at the end. So that's all I need to do in order to get my new function. Now, in order to graph this, I would go to the point -5, 3 and put my vertex. And then I would use a slope of +1 going in the right and -1 going to the left. So that would look like this. So I moved to -5, +3 right here. And then I used my slope, +1 slope going in this direction and -1 slope going in that direction. And I'm allowed to do that because I didn't do any stretches or compressions or anything like that. Now, that's it for this video, but I do have another video where we do the stretches and compressions, and we do reflecting across the x-axis or the y-axis. So make sure you watch that. It's not quite as easy as the translations.